In this video, we will learn how to draw the schematic diagram in EasyEDA from scratch. Right now, you can see the EasyEDA opened up in the Google Chrome tab. So the schematic that we will try to draw from scratch will be of TPS 62933 IC. Here is the data sheet of that IC, and normally in the data sheet the application circuit of the IC is given by the manufacturer. So first of all, we will search if there is any application circuit of this IC, right? So this is the circuit that we will learn to draw in the EasyEDA software. Here you can see this U1 is the TPS 62933 IC, and you can see some biasing capacitors, biasing resistors, and some connectors, and finally you can see this is the since it's a voltage regulator, so it regulates input 5.5 volt to 30 volt to fixed 5 volt 3 ampere, right? So let's move to EasyEDA and start the schematic from the scratch. So in the EasyEDA, first of all, we'll create a new project. We'll go to File, New, and Project, right? For creating the project, we will rename it as Test Project, right? And we will save that. After saving the test project, we can see that EasyEDA itself has created this sheet 1, which is the schematic capture page to draw the schematic diagram, right? So first of all, we have to search the TPS 62933 IC in the EasyEDA library. So let's go to the library and search TPS 62933. Here we have found the IC, and now we will just place the IC anywhere in the schematic, right? This is the 8-pin IC, which is exactly the IC which is given in the data sheet, right? After that, we will open the LCSC electronics for the biasing components of the IC, like resistors, capacitors, and inductors, right? So first of all, we have to find these capacitors, the 10 microfarad capacitors, and we have the 10 microfarad capacitor C1, C2, and do we have any other 10 microfarad capacitors? No, we only have two 10 microfarad capacitors, right? So first of all, we'll go to the capacitors portion, and we will search the capacitors, right? In the capacitors portion, we will search for the multi-layer ceramic capacitors, which are SMD, right? And in the capacitors tab, we will search the 10 microfarad. We will go for the in-stock capacitors, and we will select the voltage rating to 35 volts, and it will filter out 50 of the capacitors. We will apply these filters in the LCSC electronics, and here we have number of capacitors, so we can select any of them, and just copy its LCSC part number from the LCSC electronics and go to the EasyEDA schematic, its library, and paste that part number here. We can see that EasyEDA has found the 10 microfarad capacitor, right? So we need two of them, so we will just place two of the 10 microfarad capacitors here. Now next we can see that we need 100 nanofarad capacitor C3, right, and 100 nanofarad capacitor C5 and 100 nanofarad capacitor C8. So we need three 100 nanofarad capacitors, right? So we will reset this filter and we will select the 100 nanofarad capacitors and apply the filters. After applying the filters, we can see that LCSC Electronics has filtered out these 100 nanofarad capacitors. We will copy the LCSC part number and paste that part number in the EasyEDA library and see if there is 100 nanofarad capacitors. So we have found the 100 nanofarad capacitors. We need 3 of them, so I'll just place 3 of the 100 nanofarad capacitors here. Next we can see that we need 2 capacitors of 22 microfarad, right? So we will close these tabs which we don't need, and we need 22 microfarad capacitors. Here are the 22 microfarad capacitors. We will just apply the filters, select the first one or second or third, just copy this capacitor and search it in the LCSC Electronics, EasyEDA library. So here we have found 22 microfarad capacitors. We need 2 of them, so these are the 22 microfarad capacitors, right? Next what we need is 511K resistor, right? So we'll go to the LCSC, we'll search the resistors, chip resistors, and the value of resistance is 511K. It should be in stock, and it should be 1206. Let's see if this resistor is available in the EasyEDA library. I'm just copying the LCSC part number and pasting it in the EasyEDA library to see if this resistor is available. Oh, it's not available, right? So we will just search the next one and see if that one is available. Yes, 511K resistor is available. So we will just place the 511K resistor here for now, right? Next we need the 88.7K resistor, which is R2 in the schematic. 88.7 kilo ohms. Let's copy its LCSC part number and search it in the EasyEDA library. Yes, we have the 88.7K resistor. Next, we need the 33 nanofarad capacitor, right? So we will just reset this one and write 33 nanofarad here and apply these filters. Let's see if this capacitor is available in the EasyEDA library. Yes, this capacitor is available. We only need one of this capacitor, so we'll place this here. It's 33 nanofarad capacitor, right? So in its value, let's write 33 nanofarad for our own understanding, right? Okay, next we need the 10.2 kilo resistor. Let's find the 10.2 kilo resistor. Here is the 10.2 kilo resistor. Let's copy its LCSC part number and see if this is available in the EasyEDA library. Yes, 10.2 kilo resistor is available, so we only need one of them. This is the 10.2 kilo ohms resistor, right? We have the 511k resistor, we have the 88.7k resistor, and we have found the 10.2 kilo resistor. Next, let's find the 53.6k resistor, right? (53.6k) resistor. Let's see if this is available in the EasyEDA library. No, it's not. It's not available. Let's see if the next one is available. 53.6 kilo resistor. It's also not available. Let's see if the third one is available. Normally we try to make sure that that part is selected which is available in the EasyEDA library, right? So we have found the 53.6 kilo ohms resistor. I will just place it here. Okay. Now we need the 49.9 ohms resistor. Let's see if we have the 10.2k resistor. Yes, we have. Now we need the 49.9 ohms resistor, right? So let's search that. This is the 49.9 ohms resistor. Let's apply the filters. And see, yes, we have the 49.9 ohms resistor in the EasyEDA library, right? Now the only thing which is remaining now are the 3-pin 2-pin connectors and this 6.8 microhenry inductor, right? So let's find out the 3-pin and 2-pin connectors first. In the connectors portion, we will just go for the pin headers, right? And we need 3-pin and 2-pin headers, right? So first of all, we will apply the filter of in stock, that is the headers should be available on this LCSC electronics, right? And in the number of pins we can select the 3 pins. Let's apply these filters. And copy the LCSC part number of this header and search it in the EasyEDA library. Yes, we have the 3-pin header. Next we need the 2-pin header, so we will just select the 2p from the number of pins filter and apply these changes. This is the 2-pin header. Let's see if this header is available in the EasyEDA library. Just copy its LCSC part number and paste it in the EasyEDA library. Yes, we have the 2-pin header as well, right? Now the only thing which is remaining right now is the 6.8 microhenry inductor, this one. So let's search for the inductor. In the inductor, this one is the inductor, these ones are the SMD inductors. 6.8 microhenry, this one. Let's select the option of in stock and apply these filters. Let's see if this inductor is available in the EasyEDA library. Yes, this inductor is available, so we will just place this inductor here. Okay, now let's start the schematic diagram. First of all, we can see that the 3 capacitors are connected in parallel. The C1, C2, C3. C1 is of 10 microfarad, C2 is also of 10 microfarad, and C3 is of 100 nanofarad, right? So 10, 10 and 100 capacitors. This is 10 micro. You can just press R in the keyboard and rotate them. These two are of 10 microfarad and the third one is of 100 nanofarad, right? These 3 are supposed to be connected in parallel, so we will go to the wiring tools and select the wire. Right? Also, the resistors R1 and R2 are connected in series, which is 511K and 88.7K. Right, this one is 511K and this one is 88.7K, right? So these are connected in series and both of them are connected right here. Right? So let's add these resistors as well. Right? Now there is a 3-pin connector which is connected in the center of this R1 and R2. So here we have the 3-pin connector. One of its pin is connected at the center of R1 and R2, right? Like this one. and its second pin is connected to second pin of the IC. This here we have the IC. We will select the wire from the wiring tool and connect its second pin to the second pin of the IC. The first pin of the connector is connected to ground, right? Okay, for now connecting the ground, we will go to the wiring tool and select this net port. We will press R in the keyboard and connect this net port here. We will just double click on the label and give its label to ground. Now this ground is also available on the other leg of the 88.7K resistor, right? So we will again select the net port and connect it here, the other leg of 88.7K resistor, right? This ground is also connected to pin 4 of the IC, right? So let's connect pin 4 of the IC with the ground. Okay, now we can see that the other leg of C1, C2, C3, the R1 resistor is connected to pin 3 of the IC, right? We will select the wire from wiring tool and connect this one to the pin 3 of the IC, right here. Or we can press Ctrl Z and start the wiring from here. It doesn't matter. Right? Okay. Next, we can see that there is a 2-pin header with the pin 1 of the IC, and the other pin of the header is connected to the ground. We can just ignore this R3 resistor because its value is 0 ohm, so it's technically short, right? So here we have the 2-pin header. We just need to connect its first pin with the first pin of the IC and its other pin with the ground, right? We will just save the schematic. Okay. Now we can see that there is a 33 nanofarad capacitor which is connected to whose one end is connected to pin 7 of the IC and other end with the ground. 33 nanofarad capacitor. Okay, we don't have the 33 nanofarad. Okay, we have the 33 nanofarad capacitor, this one, right? Its one end is connected to pin 7 and the other end is connected to ground, right? We will just save the schematic. Okay, now we can see that 53.6K resistor and 49.9 ohm resistor are connected in series. These two are connected in series, and the 10.2K resistor is connected in parallel. Here we have the 10.2K resistor. We will just rotate it and connect it in parallel, and the other end of 10.2K resistor is connected to ground, right? And all of this connection is going to the pin 8 of the IC. Pin 8. This is the pin 8. Right. Now we can see that pin 6 of the IC is connected to one leg of the 100 nanofarad capacitor. We can just ignore this R4, it is of 0 ohm resistor, so it is basically, technically it is short, right? So the 100 nanofarad capacitor with the pin 6. This is the 100 nanofarad capacitor, and this one here is the pin 6. And in series with this capacitor there is 6.8 microhenry inductor. This is the inductor in series, and pin 5 is connected to the center of this C5 and L1. Now this is pin 5, it is connected right here. Now C6, C7 and C8, two capacitors are of 22 microfarad and the third one is of 100 nanofarad. These are two capacitors of 22 microfarad and the third one is of 100 nanofarad, right? Let's connect them in parallel. And the other end of these capacitors is ground, right? And the series combination of 53.6k resistor and 49.9 ohm resistor is connected to the top parallel combination of C6, C7 and C8. Which means that this one is connected to this place, right? And now we need to rename our output as Vout and input as Vin, right? So this is our net port, this is our output, which will be renamed as Vout, and here we have the input, which will be renamed as Vin, right? So this is how we create the schematic diagram in EasyEDA from scratch. I'll just repeat the steps. First of all, we created a new project and we renamed it as the test project. After creating the new project, the EasyEDA itself created this schematic capture page, and then we opened up the LCSC Electronics website, and the schematic that we wanted to create in EasyEDA, we searched each and every component in the LCSC Electronics, and we copied the LCSC part numbers of those components from the LCSC Electronics website, and we searched those part numbers in the EasyEDA library, right? The components that we found in the EasyEDA library, we placed them in the schematic capture page, and after placing them in the schematic capture page, we just did their connectivity as per the given schematic in the data sheet of the TPS 62933 regulator, right? So after completing the schematic, we will just save it, And this is how we create the schematic diagram in EasyEDA from scratch, right?